All right, let's look at the orange part of your review that goes over lesson 6.2. Now for this first one, it says if I invest $1,000 in my bank account and earns 3% interest compounded quarterly, and I don't touch it for 10 years, how much money will I have? Remember here you want to use that formula for a compound interest, where n represents the number of times compoundedly over the course of a year. So our initial amount, our principal balance is $1,000. Now your rate, remember we change that to a decimal. We never work with percents, we always change it to a decimal. So you move the decimal to the left 2 places, we get 0.03. It's compounded quarterly, so n would be 4, and we're not going to touch it for 10 years. It'd be 4 times 10. Now, on your calculators, some of you guys, when you do the caret button, it just does simply that. Some of you guys, when you do the caret button, it moves the cursor up on top, so you don't have to worry about this. But if you just type in the caret button and it doesn't do anything, then you want to make sure that you do one of two things. Either multiply 4 times 10 and type it in as 40, or put it in parentheses, so otherwise it'll only raise it to the 4th power and then take the total answer times 10. We want 4 times 10 both as an exponent. So you either have to do it in your head and say 4 times 10 is 40, or put the exponent inside of parentheses. All right, so when you do that on your calculator, we get, round to the nearest penny, we'll have $1,348.35. How much that would be worth after 10 years. And again, that's without touching it, so that's just a bunch of free money. And how much free money is it? Well, we call that interest. So if I subtract the original investment, that $1,000, we're left with $348.35. So that's how much free money we get in interest. All right, let's look at number 2. It says the median home price in Edina is $560,000. If you get a 30-year mortgage at 4.5% interest compounded monthly, how much will you pay for a $560,000 house? All right, so remember, we're using that compound interest formula. So to find our total amount, we would take our initial amount, which in this case is the purchase price for $560,000. Our rate is 0.045. Change that to a decimal. 4.5% is still a percent, even though we see a decimal there, so we move the decimal to the left 2 places to get 0.045. And it's compounded monthly, so n would be 12. And so we'd have 12 times 30. So again, if you saw that in the previous example, do the caret button. For some of you guys, it gives you it automatically moves the cursor up to the exponent. If it doesn't do anything, you want to do one of two things. Either multiply 12 times 30 in your head and get 360. Otherwise, make sure that you put it in parentheses. So that way your calculator will recognize that both 12 and 30 are both exponents, not just the 12. All right, so when you do that on your calculator, though, we get total amount of $2,154,000 or $710.91. So $2,154,710.91. That's a lot of house, where originally you paid $560,000 for it. All right, let's look at number 3. Your bank offers a savings account that compounds continuously at 5% annual percentage rate, or a savings account that compounds monthly at 5.25% per year. All right, so remember, oftentimes we do the percents, they just give it to you as an annual percentage rate, but then compounding says, well, how many times we're going to break up that interest rate over the course of the annual year. So over the course of the year, how many times is it going to be broken up? And this one's going to be broken up continuously, so that's where we use PERT. So for the first part of A, our principal is going to be if you can use a compound continuously. If you continuously compound account and save $500 for 10 years, how much will be in the account? So our initial balance, our principal is 500 times E. Our rate would be 0.05 times our time, which is 10 years. The nice thing is when you type this in your calculator, it automatically gives you you type in E, it automatically gives you the caret with an open parentheses because it knows it's going to have an exponent, so you don't have to worry about remembering to put it in parentheses. It'll automatically do that for you. So that gives you the total amount. So the total amount after 10 years would end up being $824.36. Now part C, it says if you use the other account, how much would you have? So the other account is compounding monthly at 5.25% per year. So we still have the same original investment, the $500. We're going to use a different formula. So it'll be 1 plus r over n. So our rate, 0.0525 this time, over n. It's compounded monthly, so n would be 12. And then we have a 12 times 10. It's your exponent. Again, when you hit the caret button, make sure that you put 12 times 10 inside of parentheses. If it doesn't automatically move the cursor up for you. So that way you make sure that the calculator knows that both the 12 times the 10 are both exponents. Or you can just multiply it in your head and know that 12 times 10 would be 120. Regardless, when you type that in your calculator, you get a little bit more than what we had in the previous one. We get $844.26. So that's your answer for lesson 6.2 part B. All right, on the back, on the gold side, still sticking with the gold side, these are just, this first section is just understanding how to simplify logarithms. Now remember, if there's no base, base is 10. Remember what logarithms equal are an exponent. So if you're trying to figure out what this would be, again, without a calculator, we would say, well, 10 to what power equals 1,000? 10 cubed would be 1,000. So x would be 3. In other words, this value would be 3. So remember, we're always looking to see what's the exponent. So what exponent would I apply to 3 to get 81? Well, 3 to the 4th power is 81. What exponent would I apply to get 9 to get 9 to the 5th power? Well, the bases are the same, so we can compare exponents, so x would equal 5. So my answer would be 5 for this one. 2 to what power equals 64? Well, remember, 2 to the 5th power is 32, so maybe you have that one memorized. But 2 to the 6th power would be 64, so our answer would be 6. Moving right along. Now this one gets a little trickier because we have a base of 1/2 to what power equals 32. Notice how 1/2, obviously that's a fraction, 32 is not. So how could we change this fraction so it's not a fraction anymore? Well, that would make it a negative exponent. So having a negative exponent would turn that 1/2 to just be a 2, not a negative 2 or a negative 1/2. So now 2 to what power is 32? Well, I just said it. That's going to be 5. So 2 to the 5th power is negative 32. So 1/2 to the negative 5th power would be 32. And anything, so we're trying to figure out what exponent would apply to 4 to get 1. Anything to the 0 power is 1. So your answer there would be 0. All right, for number 7, we're just changing the form this is in to write it in logarithmic form. So our base is 5. Our value is 1 over 125 equals our exponent, which is negative 3. That's all you had to do for that one. Just get it in log form. All right, so for these, we're going to solve this equation. There's a couple different ways we could do this. I'm going to do this one by changing the form it's in. Before we do that, though, anytime we solve any of these, regardless of what method we use, we always want to get the base by itself. So base is e to the x minus 4 power, so I'm going to start by adding 11 to both sides. So I get e to the x minus 4 power equals 20. So if I write this in logarithm form, which is what I'm going to do, I would have a log with a base e. Now remember, what's log base e the same as? Log base e is the same as natural log. And our value is 20 equals our exponent, which is x minus 4. So now we can take the natural log of 20 in your calculator. You get 2.9957. Now we would add 4 to both sides. We get 6.9957. All right, let's look at the next one. So here we have something that's already in logarithm form. And it's a common log. Our base is 10. So remember we talked about changing the form it's in if you're ever stuck. So we change this to exponential form. So when you do that, we get x plus 7 equals 10 to the 4th power. So if you don't have me as your teacher, a very simple trick to change something from logarithm form to exponential form is, remember, logarithms are always equal to your exponents. So if you just take your base and drag it over to the other side, then the log disappears. We'd have 10 to the 4th on the right, or 10,000. So now I can just subtract 7 from both sides, and we get 9,993 is our answer for x. This one's kind of similar to the previous one. We already have the natural log by itself. So now I'm going to change the form it's in. Remember, natural log is the same as a log with the base e. So this time I'm going to drag it this way to the other side of the equation. So we would have e to the fourth power equals x minus 5. Well, e to the fourth power, that's 54.598. So to solve for x, I would add 5 to both sides, which gives me 59.598. Well, that's it. That's how we do the gold section. So hopefully that answers the questions you had from there.